Chapter 7: Algorithms and Flowcharts. About the chapter: Introduction, Algorithms, Flowcharts, Looping. Introduction. It's a human endeavor to solve a problem by arranging the task into a sequence of logical steps. Humans' tendency is to refine each of the sequence of logical steps to form a more and more efficient solution. This not only gives a better understanding of the problem, but also gives different ways to solve the task in a better and efficient manner. This chapter introduces you to two tools used by programmers for computing to solve a given task, namely algorithms and flowcharts to automate the process of solving the problem. Though these tools might look simple, nevertheless, it forces you to think about the solution to a given problem in a sequence of logical steps, thus making the problem whatsoever complex broken into simple processes. It is like divide and conquer, where the problem at hand is broken up or divided into a sequence of logical steps to solve or conquer a given problem. Algorithms. A step-by-step procedure for solving a given problem is called an algorithm. To create an algorithm for a particular task, one must create steps which must be unambiguous and have a clear stopping point. The algorithms that you develop can be implemented by any programming language to solve the problem in real. Here are few examples of different algorithms or various operations. Quick fact: an algorithm is a step-by-step procedure for solving a problem. Examples of algorithm. Here are some sample algorithms for creating a procedure to solve a task. Example 1. Write an algorithm to multiply two numbers whose values are 12 and 7 respectively. Step 1. Start. Step 2. Let the first number be 12. Step 3. Let the second number be 7. Step 4. Multiply both the numbers. Step 5. Display or print the result. Step 6. Stop. We can see that to add two numbers, how logically the steps are arranged in order. Quick fact: start and stop is usually used to mark the beginning and end of an algorithm. Example 2. Write an algorithm to accept two numbers and find their sum. Algorithm. Step 1. Start. Step 2. Accept the first number in A. Step 3. Accept the second number in B. Step 4. Sum A plus B. Step 5. Display sum. Step 6. Stop. Explanation. In step 2, the first number to be added is taken as input from the user and stored in A, which is a name given to a memory location called variable. In step 3, the second number to be added is taken as input from the user and stored in variable B. In step 4, the two numbers, that is A and B, are added and stored in variable sum. In step 5, the result, that is sum, is displayed. Example 3. Write an algorithm to accept time in minutes and convert it to seconds. Algorithm. Step 1. Start. Step 2. Accept the time in minutes in M. Step 3. S is equal to M multiplied 60. Step 4. Display S. Step 5. Stop. Explanation. After accepting the time in minutes in M, in step 3, the time that is accepted in minutes M is converted to seconds by multiplying by 60 and stored in S. Example 4. Write an algorithm to accept a number and check whether it is greater than 50 or not. Algorithm. Step 1. Start. Step 2. Accept a number in N. Step 3. If n greater than 50, then display greater than 50, else display not greater than 50. Step 4. Stop. Explanation. After accepting the number in n, in step 3 it goes on to check whether the value in n is greater than 50 or not. If it is, it should display greater than 50. Otherwise, it will display not greater than 50. Flowcharts. A flowchart is a diagrammatic representation of an algorithm. Thus, flowchart gives a visual representation of the logical sequence of steps and decisions needed to perform a particular task. Each step in the sequence is noted within a shape, which in turn determines what type of process is being carried out. These shapes are linked by connecting lines and directional arrows to represent the order of execution. Quick fact: a flowchart is a visual representation of the logical sequence of steps and decisions needed to perform a particular task. Flowchart symbols. Unlike algorithms, which is not standardized, flowcharts have to extend their shapes according to a standard method. Below are some of the standard shapes that are used in a flowchart. Name, symbol, function, start or stop or terminator. It is used to indicate the starting or ending of an algorithm. Input or output or data. It is used to indicate any input or output process. Thus, it may be used to accept values for the user, input, or display processed data, output to the user. Process. It is used to indicate any type of process or calculations that is being performed. Decision or condition. It is used to check for a criteria or a condition that can either be true or yes, or false or no. This decision should have only two answers, true or false. Connector. It is used to show a jump from one point in the process flow to another. It is usually used to avoid crossing other flow lines or shapes. Connectors are usually labeled with capital letters A, B, AA to show matching jump points. Flow lines. It is used to show the direction in which the process flows. Flowcharting design guidelines. The following guidelines should be kept in mind while drawing a flowchart. 1. A flowchart should always begin and end with the terminators to indicate the start and stop. 2. The symbols should be accurately used during designing. 3. The flow of control is shown using flow lines. 4. Only one flow line should come out from a process symbol. 5. Only one flow line should enter a decision symbol, but only two flow lines, one for each possible answer, yes or no, should leave the decision symbol. 6. If the flowchart becomes too complex, it is better to use connector symbols to reduce the number of flow lines. 7. It is better to avoid intersection of flow lines. Quick fact: a step-by-step visual representation of a program is called flowchart. Examples of flowchart. 1. Draw a flowchart to input a number and display it. Flowchart. Start, input n, print n, stop. Explanation. As you can see, a flowchart begins with the start symbol and ends with the stop symbol. The flow lines show the order of execution. The second input or output symbol, a parallelogram, is responsible for accepting the number from the user into the variable n using input n. The next input or output symbol is used for displaying the content of the variable n using print n. 2. Draw a flowchart to input two numbers and find their sum. Flowchart. Start, input A, B. C is equal to A plus B. Print C. Stop. Explanation. First, the flowchart begins with the start symbol marking the beginning of the process. Second, next, the input or output parallelogram symbol accepts two numbers into the variables A and B from the user using input A, B. Third, the process rectangle symbol next is responsible for performing the processing, in this case adding A and B, and storing it in variable C using C is equal to A plus B. Fourth, next the input or output symbol is used to display the added result stored in the variable C using print C. Fifth, the flowchart ends with a stop symbol. 3. Draw a flowchart to input a number and check whether it is greater than 100 or not. Flowchart. Start. Input A. Is A greater than 100? No. Print not greater than 100. Stop. Yes. Print greater than 100. Stop. Explanation. First, the flowchart begins with the start symbol. Second, the input or output symbol is used to accept a number from the user into the variable using input A. Third, the decision symbol, rhombus, is used to check for a condition, and in this case, it checks whether the value in A is greater than 100 or not. Note that there are two outlets that results from it, as the answer may be yes, true, or no, false. Fourth, in case the condition in step 3 results in yes, that is, the value of A is greater than 100, it results in executing the flow line marked yes, which connects to the input or output symbol, which in turn displays print greater than 100. And in case the condition results in no, the flow line connects to the input or output parallelogram that displays print not greater than 100. Fifth, whatsoever the input or output box that gets executed, it ultimately results in ending the flowchart by connecting to the stop terminator. 4. Draw a flowchart that accepts a number and check whether it is a positive number, negative number, or a neutral, 0 or not. Start. Input A. Is A less than 0? Yes. Print positive. No. Is A less than 0? Yes. Print negative. No. Print neutral. Stop. 5. Draw a flowchart to input marks in two subjects and display pass if the average is greater than or equal to 50. Otherwise, display fail. Start. Input A, B. Average is equal to A plus B divided by 2. Is average greater than equal to 50? Yes. Print pass. No. Print fail. Stop. Looping. Looping is the process of repeatedly executing a group of statements. Using looping, you can execute a statement or group of statements repeatedly. Looping is also repetitive structure as it forces execution of a group of statements repeatedly. Let us learn the process of looping using the following example. Example 1. Algorithm and flowchart to display the first 10 natural numbers, that is 1 to 10. Algorithm. Step 1. Start. Step 2. I, 1. Step 3. Display I. Step 4. I plus I. Step 5. Repeat steps 3 and 4 as long as I less than equal to 10. Step 6. Stop. Flowchart. Start. I is equal to 1. Print I is equal to I plus 1. Is I less than equal to 10? Yes. I is equal to 1. No. Stop. Flowchart. First, I is initialized with 1. Second, the value of I is displayed next. Third, the value of I is incremented by 1 and overwritten into Y. Fourth, thereafter step second and third is repeated as long as the value of I less than equal to 10. Example 2. Write an algorithm and draw a flowchart to find the sum of first 5 natural numbers. Algorithm. Step 1. Start. Step 2. I, 1. Step 3. S, 0. Step 4. S plus I. Step 5. I plus 1. Step 6. If I less than equal to 5, then repeat step 4 and 5. Step 7. Display S. Step 8. Stop. Flowchart. Start. I is equal to 1. S is equal to 0. S is equal to S plus I. I is equal to I plus 1. Is I less than equal to 5? Yes. S is equal to 0. No. Stop. Flowchart. Here, variable I is initialized with 1 and S with 0. The next statement, S plus I, adds up the value of I in S. I plus 1 increments the value of I by 1. This process of adding up the value of I into S and incrementing the value of I continues as long as the value of I less than equal to 5. As you can see in the figure below, the value of I and the corresponding value of S. Thus, at the end of the repetition, the value of S displayed in 15. Let's recall. An algorithm is a step-by-step procedure for solving a problem. A programming task consists of two phases, namely problem-solving phase and implementation phase. A step-by-step visual representation of a program is called flowchart. A flowchart begins with a start or stop symbol. A parallelogram is used to represent an input or output process. A rectangle is used to represent processing. A rhombus is used to take decisions. A connector is used to connect flow lines. Flow lines are used to represent the direction in which the flowchart is